All right,
All right. Welcome
everybody.
to
Yoshiki.
Oshma presenting.
Renkon-pad. So let's yeah, this is too cute. So I want to introduce Yoshiki Oshima. I've had the pleasure of working with him, being his colleague for many years, first at VPRI, then at CDG and HARC. He's done a lot of interesting stuff. At VPRI, he worked on Squeak and eToys, among other things, for his PhD. He made this programming language called Kadama that's really interesting, lots of particles that you can program from eToys and see emerging effects and stuff in systems. And yeah, there's a lot more than I could say, but he does a lot of really interesting stuff. And here today he's here to talk about Renkon-pad, which is a new project he's working on with Adam, who's here, and someone else whose name I don't recall. But I'll let you introduce yourself.
Okay. I should share my screen, I think.
Yeah, sorry, I just
okay.
okayed it.
Make sure I don't expose my private emails. Yeah. So okay. This makes it hard to. Do you see like the Model T
We see your
color?
Model T.
Okay,
Yes.
good. Yeah, thank you for thank you for like giving me this time. This is great, really. And I want to talk about a few things.
Oh, Yoshiki, before we get really into it, would you like us to hold questions until the end?
Oh, so yeah, so let's see. So I have my own agenda, and I want to go to like the collaborative software making part. But we have like hours, right? So
Let's keep it to,
1
if
hour?
you have like an hour and a bit, then we'll try and keep it to like 90 minutes. And then if it's really, people have a lot of questions, we can run a little long, but
Okay, then probably yeah, holding questions, big questions later will be good. Clarifying questions will be always welcome, but probably.
yeah, I'll also try and represent the de-jargonizer for people and ask you to clarify things if I think they might be domain jargon. But anybody else is always welcome to ask for clarifications. We have a whole range of different people with different backgrounds and experience here. So if you don't recognize a term or something, feel free to sort of ask in the chat or put your hand up, and
Right.
I will try and also, if I catch anything, I'll jump in.
Yeah,
so take it away, Yoshiki.
Okay, and I'm not gonna be able to pay attention to the chat. So
Yeah,
if
I'll keep an eye
something
for you.
comes, yeah, okay. Yeah, so so I'm going to talk about a programming environment, and it's called Renkon-pad. But yeah, before that, Alex did a nice introduction, but I'm not gonna do it by myself. But if you scan this one, yeah, you can see my personal page. But if you scan this one, you can view it with your friends. So if you wanna, yeah, anyway, so maybe scan it and sort of browse it while I'm talking, and that might be fun. And okay. And yeah, I have some agenda today, like I said. So first and foremost, yeah, let's have some fun. But besides that, I want to show the Renkon language. That's like a programming language I made, and then demonstrate the Renkon-pad environment. That's the programming environment to the Renkon program, to programming. And so that's sort of the original idea, but last few weeks, I have gotten some progress on making collaborative apps written in Renkon. And I want to talk about that. And then this topic, it's sort of back of my head for a long time, but is there, the way I do collaborative apps tends to be very network fast, but in the real time and super fast kind of stuff. But yeah, the question is that, is there a best of both worlds of network fast and local fast? And we kind of I want to talk about that. if we have some like ideas in time. So the the background of the Renkon and Renkon-pad is a local AI project called Project Substrate. And we found out that there are other projects called Substrates, but this is the one Adam Bohengel here started, and I am helping. And the idea is that that's a local AI project. So you would have a computer at your home or office, and you use it as a local AI computer. But we wanted to have a sort of the interface that's a programming environment that can program stuff with AI for AI, but also AI can improve the environment itself. And the AI and you can improve the environment itself. So that's something I wanted to have. And yeah, we looked around and in some ways, but I like FRP and I like object-oriented programming, but I like FRP too. And I wanted to have a like practical environment that's based on FRP, functional reactive programming. And in one sentence, FRP is a one-way propagation-based constraint solver with an explicit notion of logical time. So it's basically time-aware programming language, and then you have a basically nodes and wire diagram logically, and when some node changes, the change is propagated through the dependency network, and everything gets evaluated. And it's a kind of the data flow language, but the FRP, at least the original conception, had the interesting idea of separating behaviors, which is a time varying like variable on the continuous time domain, and the events that's on the discrete time domain. And as I write programs in data flow, this separation is like very useful and nice, so I keep it. And then anyway, the good property of FRP is that at the quiescent times, so the propagation happens, then it stops, and this is sort of steady state. At a steady state, the relationships expressed in the program are satisfied. I'm going to show examples in a minute, but this is
Can I
very
ask
nice.
can I ask for a quick clarification on this? Because
Sure.
there's a lot of different like signal libraries and FRP kind of approaches out there. Is the idea that by saying at quiescent times, the relationships are satisfied, that means that when you could observe intermediate states, you don't try to sort of progress time, preventing observation of invalid or intermediate states. You just sort of say like, once it stabilizes, it should be consistent.
Yes, and also there's a notion called the synchronous language. That means that the computation does not take any logical time. So any like computation takes 0 logical time. So basically the last one says at the given logical time t, the values are, there's only one value. There's no like intermediate or such. At logical time t, there's a value for
But
behavior.
changing an upstream value could cause a lot of logical time to pass.
No, it's only one-way propagation. So changes propagation, and that's the
I'll
value.
ask more specific questions later.
Okay, sure.
Don't mean to rabbit hole, thanks.
Okay, and so we'll see examples, and then it's going to be easier to do questions. So based on that FRP concept, I created a language called Renkon. Oh yeah, so I forgot. So Renkon is a kind of root Right, yeah, as in root vegetables, you can Google Renkon and you see the root vegetable. So it's kind of a root. But also Adam had a idea called Recon. And he has Renkon. I will make a Renkon programming language. So that's how the name came about. But anyway, so Renkon is an FRP language, sort of heavily influenced by flapjacks by Leo and the Arjun. But anyway, so the surface syntax looks like JavaScript, but as I said, FRP provides a very good foundation for building a data flow based programming environment, and the FRP is well researched. As I said, I want to have a dynamic modification in a big way. And that part wasn't really done much. So I want to have a FRP language, but very flexible and malleable and dynamically changeable. So that's the Renkon language. And one more thing, so program in Renkon is really looks like a top level sequence of top level statements and looks like JavaScript. But the Renkon transpiler works on a statement one at a time in isolation. And then it analyzes the free variables in that statement and treats the free variables as dependencies for that expression. So basically so by transpiling from the JavaScript looking stuff, it creates one or more reactive nodes from the statement. And then nodes are topologically sorted based on the dependencies relationship. And then evaluator walk through when something should be done, and the evaluate, and if it goes through the topologically sorted list once, and then that's the new value for time t. So that's how it works. And let's see, this is a simple example. And do I have it? So if you go to anyway, so I paste this program here. And what it says is that, so this, as I said, so there are 3 top-level JavaScript statements. The first one says, after 500 milliseconds, the 100 will resolve to 100. And timer 1 is a FRP timer thing where it updates every 1 second or 1,000 milliseconds. And this third line has 2 free variables, 100 and timer 1. And when those values are available and different, that node will be evaluated. So if I open console, and then this one runs the program. So after 500 milliseconds, you see those values are printed. So that's Renkon program, like simple one. And then, but it's okay. But the good news is that it's easy to do like DOM manipulation. If I copy this, paste this, can you read this part? Is it too small or such?
It's fine, thanks, yeah.
Okay. So there's a timer that updates every 1 second. And this second statement has an immediately invoked function expression. I will talk about it a little bit later, but whenever timer updates, this function effectively gets invoked, and inside it does some dirty stuff like mutating the body of document kind of thing. But if I run this, so I get a button at every second, basically. So because this expression gets evaluated when timer updates, and the new button's text content is the timer. So that's what it's doing. And it's okay, but you don't want to have too many buttons. But if you use a virtual DOM library, it doesn't have to be Preact. It can be anything. Doesn't even have to be a virtual DOM. But if you use it, maybe I should create a new one.
And just to clarify a question in the chat, timer is something Renkon provides, and so the reason why the number is still high is because it's sort of running in the background all the time.
Yes, timer is a reactive node that updates itself at the specified time. Specified logical time, but it's best in general synchronized with the real time. So so that was like making new buttons at every second. But if you use a virtual DOM library, by the way, this is a modified React library. So the Renkon does not depend on any such libraries, but you can just use it. So
And you're not transpiling your imports though, right?
No, import. Yeah, this is an import expression, and so the H and render are a modified H and render coming from React library. So the event timer updates every second, and this H creates a virtual DOM. Its type is button, and sort of the content is timer. And so it's a function. It's a pure function. Given arguments, you get the new fresh DOM object. And only at the last step of this evaluation, it doesn't have to be last, but tends to be this way. But at the last step, you sort of mutate the document body, but you don't use the value out of it. If I run it, I get the one button, and that updates at every second. And this is more like what you want if you write a program. So the virtual DOM is your functional value, and at the last step, you update the screen if you want. So the Renkon does not depend on graphical library, but you can use it you can use any library basically. And that's good, and that's like basics of Renkon is covered. But the interesting thing is the combinator. So the basic rule is that if you have free variables, more than one, let's say, and then you get evaluated, or the node, a node has more than one free variables, and the node gets evaluated when all values are available. That's the basic rule. If you want to write a bigger program, that is not enough, and that's where the combinators are useful. So let's say one example of combinators called events or. Let's see. So up to here, it's sort of setting up the DOM, so don't worry about it. And this events listener is really like the JavaScript's add event listener. And basically, whenever click happens on an element called up, this up event stream gets a new value. And the down gets a new event value when the click happens on down. But the main thing is here, you can say event or up or down. So this breaks the basic rule. Either it doesn't require two values to be available. Either up or down will update the up or down event. And then when that gets updated, a DOM node text content gets updated. So if I press up, it says up, down, down, up, down, down. So this looks like starting to look like your graphical user
And-
interface.
Just to make sure I'm understanding this right, so what's happening is, although this, I mean, this looks a lot like sort of vanilla JS. But what's actually happening is this is basically being transpiled, pulled apart into a whole bunch of pieces, creating a computational graph and then gluing it back together. So when you generate events from the DOM, it's flowing into this compute graph, which is updating the render state.
Yes. Yes, so yeah, so syntactically it looks like JavaScript. It can be TypeScript too, but exactly as you said, internally it was all of those nodes are transpiled and then dependencies are figured out. So in many ways, like the order of those definitions in your program absolutely does not matter. You can write stuff in any order and you get the identical behavior. So
Is that true though? Because doesn't the order help the transpiler know how to bind the variables to the
no,
right
the
places?
transpiler does not bind. Each node is independent, it knows what free variables to look for. And first, yeah, all nodes are transpiled, and then
This works if you use const, right? So, but if I used let,
no. When a node is changed, then that may depend on a definition for a node bound to the same. Yeah, I can just change it, for example. So what's a good one? I don't know, plus hello. And I running here, pressing this button means that take the program text and then transpile and run it inside. So I run it, and now it says hello. And yeah, if there's a timer, yeah, console let, it doesn't matter actually, timer equal 1000.
right? But if you put down below the last line there, const
Yeah,
down.
that's fine. Because order literally does not matter. And that is a good thing.
So, yeah, I also have a few questions about the syntax and stuff, but I'm guessing it's better to save those for later because
Yeah, right. Yes. So syntax part. So you can picture this as a basically nodes and wires diagram. And each like top level, actually the top level thing and some sub expressions are those nodes in your graphical environment. And the free variables are the wires between them. So in 2D layout thing, there's no order. It's the same thing. Yeah. And so combinators. Another combinator is like collect. I like the act names for various reasons, but so it's like the followed by construct in some other languages. So how this is how you read this. So the data is a behavior that starts with an empty array. But whenever up or down event happens, the previous value of data and the new up or down event is used to compute the new value. In this case, it just appends the new name. So if I copy this,
it's like a reduce for streams. Is
yeah,
that-
read it over time kind of thing. So let's see. So data is we modified stuff a little bit. Up or down, so it should be fine, right? So if I run it, yeah, so now it keeps growing whenever I press. So yeah, this is the same program was running already. I updated a running program, and then it got a new sort of the double quote behavior. So this is sort of the example of the collect combinator, but also a dynamic update in a simple case.
Wait, so I missed that. Can you go back real quick? So if you made a modification and the output didn't like get cleared or whatever, right? It just kept going, but you had kind of different behavior for later in the output. Is that what happened?
In this case, talking like a case-based, and that's kind of bad. But in this case, the last thing was like mutating the text content of this out node here. So
Okay.
as soon as I pressed the new, it used to say up or down target ID, but now it says data. So I pressed the button, up or down got updated, and data got updated, and then text content of out got updated. Out was the same, exact same element, but it got updated to a different value.
Okay, thanks.
And so the collect is like followed by, but I have multi-arm variation for select. Yeah, it's a like actor-like thing. So collection start with an empty array, and when timer event happens, it gets a new value. But when the reset event happens, it resets to an empty array. So let's see. Oh, I think I'm gonna show this later. So that's sort of the interaction kind of thing you write to in FRP. But there's one fun example I want to show. And this one, so this one shows like what kind of fun idioms you can write when you have a time-aware programming language. So the events listener is basically just this expression I'm highlighting is a stream of events. And whenever a pointer move happens on document body, it gets a new value. But it was an event, so I converted to key behavior by saying behavior as key. So the pointer move is a stream of sort of the values that changes whenever a new pointer move happens. It's a continuous domain function, but the last pointer move is the value. So it's like a step function. And delayed is created by a delay combinator, the delay combinator. So pointer move, that function is delayed by 500 milliseconds. So that's delayed. So if you move the mouse, the delayed stream is lagged behind. But if you stop it, 500 milliseconds later, it catches up. So stayed means like whether the pointer stayed in last 500 milliseconds. And that's exactly this expression. You can just compare the latest value of pointer move and delayed one. And when delayed one have caught up, the pointer move state becomes true. So if I run this, and while I'm moving the mouse, it's red because this is red. No, this is red. But if I stop the mouse and 500 milliseconds later, the background color changes to blue. So in even React, but JavaScript, if you want to write this, you would have like a set timeout 500 milliseconds in your pointer move handler. But when the new pointer move event comes, you cancel the previous one that may be scheduled and reschedule and stuff. So it's very complicated. But here, you really can say, the pointer has been stayed if delayed one and the pointer move are the same. So it's sort of the like clean way to state that kind of stuff. And it's fun to find out or it's fun to come up with new idioms like this in FRP. So
I think this is really compelling.
yeah, so the so the syntax part is tricky sometimes, and I showed an example of immediately invoked function expressions, or IFI. And the idea is that those are like dependencies for this thing. And here I say ... but that's like a really side effect for within this function, make a array and like updating that array over and over and having for loop kind of thing. And some dirty stuff are here, but in the end it returns it's basically the SPG virtual DOM node as a function, and the graph gets a new virtual DOM node when basically I will show you, but when something is hovered over kind of thing. So you can mix sort of the imperative thing wrapped in IFI and use it, and that's kind of it feels a little fill in the blank. What is it? Fill in the blank. It feels a little iffy to include side effect or features in a purely function formation, but this is very convenient, and if you need to interface with outside, basically you can do it this way. And so that's the sort of the basic part. But to write real applications, you end up with having cyclic dependencies, and traditionally FRP cannot handle, or any boxes and wire diagram cannot handle cyclic dependencies in right way unless you have some mechanisms. And I have a few, and actually one is collect and select that is using the previous value of itself. So there's a cycle there, but when new value comes, that old value and new value is used to compute a new value. So that is a way to break cyclic dependency. But the main thing is events send and events receiver that I borrowed from Flapjacks. If I do this, so the collection is select, so it starts with empty, but the one I showed. When timer happens, it gets longer, but when reset happens, it resets. So I should make a new one. So if I run it, and the bottom DOM is a collection mapped to virtual DOM element. So at every second it grows. But when there's an event handler, and that sends reset. So if I click on any of those, it resets because of this. And this is like sort of the skeleton of UI-based application. But one thing is that this means that this bottom DOM depends on collection. But collection depends on reset, and reset is used in bottom DOM. So basically the collection depends on bottom DOM, but bottom DOM depends on collection, and there's a cyclic dependency. But by using a receiver and the send, you can break the dependency. Basically, send triggers evaluation in the next evaluation cycle, not this cycle. So that's how like a dynamically created DOM node affects the data. So oops, I'm not gonna talk about this variation, but so now we can talk about Renkon-pad, and I'm trying to explain the language and also a little bit of like how to do DOM manipulation. But with that mechanism, we can write basically full-fledged programming environment. And this actually was in Renkon-pad altogether. but the idea is that you can make basically code boxes to write Renkon node definitions. That's like code, and you can make a documentation window to write like markdown document, and the runner is the thing we have been seeing that gather all program and they run it. And there are a few ways to show the dependencies visually, but that's purely informational, doesn't affect the semantics. And there are a few nice features like comment and pinning. I'm going to show them. So I'm claiming this to be self-sustaining, even though we can debate that. So I didn't write the browser. I didn't write CodeMirror editor. I didn't write the Renkon-pad, but everything else is written in this environment itself, and you can modify dynamically. So where we are. Oh yeah, so originally the self-sustaining part, I wanted to do it, but that's secondary. Main purpose is to make applications, and I want end users to make applications. So let's see a kind of application I created. So this is, I don't know, like 300 lines program. And this part is all CSS. So typically, but this one, if I create a runner and run it and say start. So this is a rhythm game. It does a do. So it's a rock rhythm, and you are supposed to tap them. And it's impossible to do this on my trackpad. But if you run it on touch, like iPhone or iPad, and use 2 fingers, you can do this. And so FRP is often used for robotics and that kind of stuff. Then the real time, sort of controlling the real time stuff. And I want to have the real timeness really well supported. So and another thing, and also sort of writing this kind of stuff in the boxes, nodes and wire notion is fun. But one thing is that unlike like Smalltalk, when you can make a standalone application, like no editor involved, no other windows and stuff involved. This is purely a Renkon program for this game and running in its own like tab. So you can really create a self-contained, nicely packaged application, and you can run it in iframe or like by itself. So that's sort of what kind of stuff I wanted to make.
Ivan's wondering how you can get to the code for Garuba. Like, is the editor accessible somehow?
Yeah, sure.
Oh, sorry, that's not what I was asking. I was asking for the deployment example where it's like, here's a standalone nicely packaged deployment. You mentioned that it doesn't have the editor, it doesn't have the Chrome, and I'm wondering, it
has Chrome. It doesn't have like window manipulations.
Yeah. So is that stuff just hidden, or is it completely removed?
It's not even removed. It's really the pure code part is sent to saved to a file and loaded and run.
Is it interpreting, like, do you output the transpiled JS code? Is it sort of like printed, or is it like the source is somewhere and it's being loaded at runtime and transpiled?
Currently the latter. We could do the former, but yeah, the interpreter is loaded with the Renkon program, and the interpreter runs it.
So
if I could view source and edit it, I could get to the Renkon representation that's not lost in the current implementation.
That's correct. That's correct.
Cool.
Very much like Smalltalk, right? If you get kind of if you have a Smalltalk application, you can pop the hood of the thing, make a modification, and
Yeah,
But
but
you said that you don't have windows like the,
right. You don't want, it's typically like Smalltalk, you could do some packaging, but maybe your string class depends on some text editor and, or do I carry the text editor with my string class or such and sort of gets bigger. But this is clearly delineated from like a development environment.
okay.
So in the paper, by the way, so the entire Renkon-pad program is like this, like right now it got more features. So I have like 2,500 lines, but I do use the environment to improve it. And if I say graph, so basically if I said a text box can have multiple node definitions, and those lines are dependencies like import and export. Like this text box exports like the enable change, for example, and that's imported in the other one kind of thing. But later, that's the stuff I think I described in the paper. But later I figured like that's not very useful. So I changed, I should show in a different one. So let's see, I load, oops, XYZ. Wrong program. So this one program has 4 nodes and 3 windows. And X is 3, Y is timer, and the Z is X plus Y. I'm not going to show the console, but you can see what happens. But if I say show graph, yeah, X is exported from this text box to this one, and Y, Z imports. But I can say show dependencies, and if I hover here, it shows a little widget says, yeah, X doesn't depend on anything but used by Z. And like Z depends on X and Y, and there's an unnamed one that depends on Z. So this is more useful in my mind. So I use, and actually I can click on here, X, and even when the program is big, it takes me to the definition of X. So this is basically you click on the wire and you are taken to the definition. So that's kind of nice. And another thing is, so this one is gonna do, but I can create a different code block. Let's say, so const y equals whatever, 42. And this one is basically commenting, and it makes it blurry. The blurred text is commented out. I borrowed this idea from the Stride editor. And if I over here, yeah, Y, now this Y is used for this T. So when you have your experiment in your program, you can quickly like comment and uncomment to see the different behaviors. And you can instantiate multiple runners side by side, and you can compare them. So that's kind of nice. And
Did that happen automatically, or was it a side effect of kind of shadowing the declaration of Y?
No, well, this bottom blurs. Or if you really have 2 definitions for Y, for example, you get a notification in the console, but the last one will be used currently.
Okay.
It may not be a good idea, but that's how it works now. Another thing is the pin. So if I move around, sometimes like X may go outside, but if I unpin the window, it stays on the screen and you can still move around, but the unpinned window stays on your screen. So this is useful when your program is big. And so Self had a Kansas system but Randy Smith's idea was that pinning is like pinning the window to your window shield. and you are driving the car in Kansas. But here, basically pinning means that I pin the window to the background graph paper and unpin it. So you can debate which is better, but pinning is useful, and implementing pinning was actually quite hard. But try it
This
with
is an
your
interesting
user
UX affordance that I don't think I've seen anyone do it like that before.
So
that's
self-hard,
interesting.
but it's a good one, I think, actually.
Playbook has a similar.
Yeah.
Yeah, I was about to chew out Peter in the comments.
Yeah.
It's not quite the same.
It really does get pinned to the view.
Yeah. So as I said, the bootstrap version where that was enough to do like modification and save and load, that was like 700 lines. But I added like multi-touch support, like pinch zoom, and that added like 100 lines, and all like a document window, I added like 100 lines. So those stuff adds up, and right now I have like this much, but still it's kind of simple. I'm not gonna probably walk through, but some DOM elements, like code, but like this code thing was added, and when I click on like one of those, the code mirror editor is created in this new component sort of part of it, and user interaction stuff would say what to do, what kind of event like add code should do, and such. And then, oops, oh, go away. And but interesting thing is the data structure. So in sort of the MVC sense, so the model is sort of your pure sort of the data part of your program, and the rest is sort of the visualization and interaction. So the model of Renkon program, actually, let me go back to the other thing. The model of Renkon program is like just windows and contents in it, but there are different ways to represent that kind of stuff. So let's say you have two windows like those, and a typical way may be to have a like a deeply nested tree structure. So windows is like the one top level data structure, and that may be an array of windows, and each window has like position, and this one is simplified, but you may have like a deeply nested structure and one tree, but that works too. But I found it's easier to write program in this way. So it's all like separated data structure. So the windows is really just an array of identifiers, and the position is a map keyed by that identifier and have the like a rectangle object, and titles is also a map keyed by identifier and the name kind of thing. So it is like spreadsheet programming. So you would have an ID column, and each row is a window. And whenever something updates, this is nice because the dependency propagation mechanism does the right thing. You don't have to worry about, this part of tree should be mutated or not mutated, or should I use IMA, or that kind of headache isn't here. You just separate them in a separate data structure, data structures, and just write the dependency in a normal way. So
I think I'm still confused a bit by this. So if you had, maybe it would help if you spun it around and explained why that doesn't work. So if you had like windows and windows were, this way. Sorry, I was trying to construct a different example on the side, so maybe you explain this and I just like was testing something else. What's wrong with this approach?
So let's say you just want to update the X and Y of like window 2
Yeah.
by like dragging, right? So in React, like how are you gonna do it is, for example, a question. And if you just you end up with a lot of ... and the update this object here. But if you keep the identity of this object the same, React is not going to update the screen. Or it's crazy, you know, optimizing its own hell issue.
Right.
So
Right. So this is just a problem of interacting with this React outside library. If you had a
no,
different signals library, then this wouldn't be a problem.
yeah, so it's not but at the same time, you do not want to do like a deep mutation logically. You want to have a, okay, it's an opinion. That's my opinion. I like this way.
No, but I do think you have a point there, which is that like React does this whole thing with identities so that it doesn't have to do kind of deep object comparisons. And that's what Yoshiki is getting from this refactor.
Yeah, and also, in the program, I haven't shown you, we can walk through sometime at a different time, but you can really focus on like a position. If you are concerned with the position, you really write the position related thing. You don't like worry about like other parts of the big tree. So,
but doesn't this alternative approach have the same problem if you make a modification to a map? Like if I change the map's value at 2, I still don't change the value of the map.
so there's we can, yes and no. So right now, so it's actually a good point. There's right now what I consider a workaround is used. So let's say positions, that is a map, but it's not a direct map. It's wrapped in another object. And I do mutate the map itself when the mover resize event comes. But what gets returned is the fresh object actually. Just a one, so and if I have a...
So you deliberately break referential equality.
Yeah, because the equality testing is simple, but you could imagine to have your own like map equivalent, and whose set says, update the entry, but also like last modified time to be this logical time, as like a proxy or such. And then my equality test can compare the last modified time, and I don't have to do this.
I don't want to rabbit hole on this super bad, but I would love to have a follow-up conversation with you and anybody else who's interested, because Paul Sonnentag and Alex Good and I have been talking for a long time in AutoMerge, like libraries. How could you subscribe to like sub values or queries on more complicated data structures? Because you very often want to do things where you do want to say specifically, like, I want to watch the position of this window. Without having like, and you can do exactly what you're doing here, but it just feels like it's sort of you have a particular data structure being forced on you by the system rather than being able to sort of model your data naturally.
Yes and no. So it's opinion. So like I said, we could do that one big tree approach here. I've just found like a dependency, like if you are modifying, I don't know, the title and the position from one event and what it should do, etc., etc. So but we can debate.
I'd love to talk more about it and like talk about some of the trade-offs.
There's another angle that we've benefited from, just briefly, which is the paradigm that's been discussed here makes extensibility and modifying your program, you have to keep much less in your head. Because
that's true. So that's exactly. The spreadsheet model of some. But anyway, so let's move on. And just so that I'm showing the positions, let's try this. So I run this program. So this is running this program, and maybe I create a new one. But here I can say events.delay. So move or resize event happens, the position gets updated, but I can delay it maybe 2 seconds. And I run it, and now I move it, and 2 seconds later it moves. So this is exactly like inserting a delay node in your Max MSP program. And it's really isomorphic, just done textually. And yeah, for later things, I would say 0 would be better. So and also notice I didn't have to restart the program. The positions are kept, but the behavior changed. So this is nice to be able to do this. Oh yeah, so the how other parts are written. So as I say, this is really event listener on the DOM node, and that works. But unlike depending on the side effect inside, it gets a new value. So this is an event that gets a value, say, called when click happens, but it doesn't have the value at the different times. You don't have to differentiate and stuff because events are on the discrete time domain. And then this one.
Yoshiki, I want to ask a quick question about the previous thing. Since you can, it's sort of like you can add state from the outside because you have these maps that associate the identity of an object with a little bit of state. Is there a story here for like, since you're keeping the state of the entire program, even when you make a change, is there a story for initializing state that you add? I suppose I could add a new map on the fly that adds like, a Z kind of coordinate to Windows or something, and then all of a sudden I'm using it. But how would I specify what the initial Z is for each window?
So the initialize, yeah, it's sort of like the same as you do it in Smalltalk. Like you kind of have to write some. So
So there's an all instances do kind of thing.
Well, so let's say window, like I said, so Windows is simple. This is really array of IDs, but window types either called a Docker runner. It has the sort of the Windows change handler part.
Mhm.
And I'm not totally happy with this idea here, but I was thinking that you may have like a multiple add. It's the same thing, or multiple select and delete. So their windows may change by more than one Windows, ID. So I kind of have to enumerate and do stuff.
This specific example is the hell that I'm in right now.
Okay, yeah, I'm not happy with this.
And really specifically, Josh wrote some code which is very reasonable around a similar model, which is to materialize a tree of data, right? Like a folder tree out of flat arrays of documents. And that's the sidebar of this app we have. And it's so frustrating that there's no more efficient way to figure out how an array has changed idiomatically. And I don't think I've never seen an example of like tracking changes to an array or a map in a reactive kind of environment that gives you like a nice comfy user interface for it. I think in principle it could be done, but I just haven't seen it, and I think it would be very useful.
Yeah.
Like if you have a signal that's an array and you want to know like what are the elements that were added or removed in this sort of trigger of my code, you just have to do that ridiculous thing you're doing, which is ask if it includes elements and look for, right? Like you're doing all of these walks of the array. It's a mess.
Yeah, at least I only have to do it for the, that Windows array. So
it's fine, but I think it would be a worthwhile
easy.
contribution if somebody figured out
Yeah,
how to do this in a way that's
that.
like cozy, like not a weird idiom that you have to do all this extra walking.
Yeah, I agree with that. So yeah, going back to here, so in this environment, of course, when I move the mouse pointer here, it sort of drags the background. But if I do it here, it moves the window. So the pointer move has to do different things depending on where the click was or the pointer down was. And then there are a bunch of ways, but the one nice way I found was that because this is reactive, or I made it reactive, when the handler function is time varying, when this changes, the old handler is removed and the new one is installed. So whenever the function bound to move compute changes, listener changes. So that's how like the handling different types of move are specified here. And I like this way, instead of trying to add different move handlers everywhere and sort of say which one has the precedence and stuff. So it's a style that like other people can come up with better style, but having the reactive listener thing, sort of React has that too, but really push it all the way like this, in this way, it's good. And also, I want to point out that because we are interfacing with the browser, you could imagine that why do you even have to have a function like this? Like it should just have a click, like shorthand, etc. But sometimes you do have to have a side effectful thing for the event. Like I have a multi-touch or the double tap and that kind of stuff. And you really have to call prevent default in that immediate event handler. So this has to be a function, and inside you need to do some stuff sometimes, as opposed to just store it in the active node and later time process it. So having this idiom, say event listener, it looks cumbersome but very useful.
But so the double click thing is an interesting one, because you're saying like prevent default or whatever. Like by the time you know that there's a double click, there has been a single click, and so like is there a way to retract whatever you may have done in response to the single click, or like do you have a story for that?
No.
So
just
we
so
have
that single click wouldn't
we have some gesture nerds on the call, I suspect. So if they want to weigh in, but what I remember from sitting in on workshops about this and looking at the code back when we were doing a lot of multi-touch things, is that actually you delay sending click. If you want to make sure that you only get a double click, you delay sending click until you decide if it's a double click. So if you have a long double click timer, then you just don't get your single click event until that time's out. And
Yeah,
that's
but
one of those like really frustrating
that's not
design trade-offs.
the better idea, I think, is sort of the universal design where single click doesn't have to be canceled. Like in MS Word, and the triple click selects paragraph, but it's okay if you change your mind after double click and it still selects a word. And the third click can be very late, and so that's a better design, I think.
I think the thing that bugs me about all this stuff, I agree with what you said about universal design. I think there's a way to design your interface so that it's not it's not a big deal. But there's something very non-modular about, like if you think of what you're doing in response to a single click, and then all of a sudden someone says, oh, but I want to have a double click thing. They really have to understand what you did with single click first, I guess.
Yeah.
And maybe this is not a problem that we want to solve, I guess, but
right. Well, yeah, when it has to be solved, yeah, we have to do something. Sure. Yeah. So I should probably mention this doc editor creates a markdown editor, and I can say, income. Oops. So. So this is basically another mini app written in Renkon-pad doing this, but it's good that my Renkon-pad program basically has those documentation, and you can write more elaborate documentation more than like you writing comments in the text, but you can use like Markdown and you can actually embed other HTML pages by having like iframe in here, for example. So I don't know, it's nice to have different types of windows, and your program is explained more in detail than comments. Although I don't write comments as much, but that's sort of what this environment supports. Oh yeah, so this was, so I can do some program manipulation, and let's say what I want to, so I was talking about, text box having multiple node definitions. So there are like 8 windows, but there are like 150 reactive nodes. But what if I make a text box for every single node? So this program I paste in, basically Renkon is like the Smalltalk in Smalltalk. So it's the execution context you can use from your programs. And you can say, what kind of definitions do I have? And make a new saved data and run it. So if I run the Renkon-pad program with this additional thing, if I run it, it creates more windows, and each window has the single definition. And yeah, this isn't, so I don't have that omakase mode of Natto, but you could imagine if I lay those things out, I can get a Renkon program. It's an equivalent program, but each node is stored in its own text box. And I can say, yeah, graphs like those. And of course, this is equivalent. So I can instantiate a runner in that, and I still get the working program. But it's an interesting question that, this isn't too crazy once you do it, but it's very hard to imagine to write everything from the scratch with like, this many windows. So
I think this is a really provocative idea here, and I think you have. I showed Alan something we did at the lab a while ago, and he said it doesn't look like what it's doing. I'm paraphrasing somewhat. And my initial exposure to Renkon-pad, that was my reaction, is it like I've really misunderstood it because it doesn't look like what it's doing. And then it took me a while of like listening to you and like looking at it to start to get the feeling of what it's doing. I read your paper, the first time you sent it over, and I didn't understand. And this looks like what it's doing, but it's hard to work with. And like, to me, that's a big puzzle, is how could you make it look like what it's doing, but also make it easy to work with? And I don't know how, but I think it would be nice. And I think that's sort of the Hazel like whole thing, is figuring out like the affordances for their weird, super strongly typed language so that they can have that good editor experience. But like this one, I think you're like, you have something that feels conventional, but is actually radical.
Yeah, well, I can say, yeah, either way. It's different.
This is connected to the couple of questions I wanted to ask about syntax too, because it's like, you made a decision to use JS syntax, but you give those programs a very different semantics than we have. And I think that can be a good thing and it can be a bad thing.
Yeah, I agree. So like, it's sort of, Nile, Dan Navian's Nile, and he has the idea that, oh, this is a data flow language and the kernel language, two languages in the, in the one syntax.
Hey, Yoshiki?
Oh, wow. Hey, I wasn't.
Yes,
okay.
I have been listening. No. So here's just a thought from the old guy. What this feels like is kind of the virtual machine for some higher level language that hasn't been designed yet.
Yeah.
And my theory is no human should be writing in virtual machines. But the incredibly valuable thing here is that you've made one in itself. It's small. It has many useful things, but most of the topics that came up during the demo are things, many of them are things that remind me of, that could be statements in some higher level form, right? There's a higher level, I think, to me, it feels like there's it would be really interesting to, now having done this, see what you could write in a higher level form that could possibly make the lower level form that you've written materialize.
Yeah, right. So that's sort of my allusion to Naive and the kernel language versus data flow language. And there, yeah, I don't have a good idea yet, but
yeah, but I mean, this
I
is,
agree
this
with
is really not
actually,
not too many people can do things in this direction, but you're very good at it. And
wow, yeah, let
you
me
know,
show
and then,
you a little bit more and you may change your opinion. So okay, so another thing I wanted to show is that, so we squeakers have a way to say whether a programming environment is powerful enough or not. And that's whether you can rotate windows.
Oh, I thought it was to evaluate 3 plus 4.
Oh, yeah. Besides that, so again, I added a new thing. And this one has a timer sort of, and then it injects CSS. So if I added this code here and I run it, the Windows is going to rotate, but this is still operational. So the code mirror doesn't know that it's rotated, and this is a shame. But you can say edit here and change your program. But this is where like the modifying really yourself can be a problem. Like if I try this and I cannot get back to the original program anymore. But if you have a separate isolated execution environment and run it, you can just kill it and get back to your experiment. So I like this separation here. So that's one thing. Grown up graph rotating window. Oh yeah, Markdown. Yeah, actually this is the Markdown editor and actually this is my Markdown editor. So my presentation, of course, is in Markdown and sort of has a little features to jump to the selected place, etc., etc. And it supports the HTML tag, so you can have stuff. Then I'm not going to show the implementation, but it's the actual part is short. Just the code mirrors update is propagated to Markdown it, and Markdown it renders the HTML. But as you start adding like this keyboard navigation, I'm pressing the up arrow and down arrow to go different places, or like scroll here and that scroll. So those things adds up, but still it's short, and you can play with it. Oh yeah, so another thing, I'm going to show a few more demos. And this is...
So, well, I was curious. I'm not sure how long this session goes for, but I'm wondering if there's going to be time for assorted questions or like higher level
later.
questions.
Just
okay, later. All right,
15
great.
more minutes.
Okay, great. I'll let you keep going.
Yeah, so this is my interface to Llama. So I can say what is... Yeah, this one didn't do much, but you can switch. But this one has an interesting thing about like drawing the character. So again, if you have a computer, yeah, like real-time stuff is fun. So you should do that. And each token generated by the Llama. Oops. So So this llama generator is a modified implementation coming from llama.cpp, and it generates like a token at a time. And my Renkon program treats the generated token as an event. And then I add the time stuff and animate. So it's kind of fun to do this, and without having to write this generator by myself. So that kind of stuff can be done. Oh yeah, this one. Oh, I thought I had more. So I looked at Natto Dev, and they have the. Oh, I'm meant to show the code too. So yeah, basically you type in keyword, and it searches from the art gallery, and you can choose the picture. And the Natto Dev has this. The main part of code is just about the same, of course. But this is a standalone application with my own CSS and stuff. So, so that's something you can do. Oh, this one, it looks like a Renkon-pad, but I have 2 more buttons, say help and aha. So if I say help and I say, what does this program print, and hit enter. And this one, yeah, I put the Renkon's documentation and the program itself in the sort of the context. Oh, it doesn't.
Question for you, Yoshiki, because I've been wondering about this through the whole talk, which is kind of tied back to Alex's question about like JS code versus semantics. It seems like my intuition would be that you get a bit of benefit from using JS as your language, because obviously there's a lot of training data for it, but you're also going to get the big disadvantage that the semantics are quite different in ways that the LLM, you'd really have to work hard to convince it to write Renkon instead of JavaScript, because it has billions of examples.
Yeah, it's a problem, I think, especially when the syntax is similar to something else. Yeah, it triggers more hallucination. So it's a big question, and yeah, I don't know whether having a totally new language nobody has ever seen, and then maybe train the LLMs, or yeah, I don't have a good answer for that question.
It's this sort of depressing thing where it's creating greater centralizing forces on an already heavily centralized ecosystem.
Yeah,
it's like driving more people to React, driving more people to like Tailwind, driving more people to JavaScript.
Yeah, I don't have a good answer.
Yeah,
But let's move on. Let's go.
Yeah.
And yeah, I have this aha button.
One idea out later.
Aha button, which doesn't do anything. But when you get an idea, you press aha, and it doesn't do anything. So, oh yeah, so that was the Renkon-pad. Okay, yeah, went longer. But like I said, what I really wanted to talk about was the collaboration stuff, and so in the previous work, I was doing the croquet stuff, and in a very small nutshell, so to speak, croquet is a multiplayer application development library. But let's say a typical like a game would be done this way. You know, you would have a beefy server on the internet, and that computes the new game state. And the user would send an event to the server computes it, and this thick arrow crossing the internet to client devices means that a large amount of data would be sent from the server to those clients. But the way Croquet does it, it's different. On the internet side, there's a thing called reflector that does not compute the state of your application. Its only job is to timestamp events and send it back to all participants. And this red part ensures the result from the current state and additional events are identical on different devices. So one user sends event, reflector only reflects back the event to participants, and these virtual computers compute the identical state. And this thick arrow is here, but it's on your device, so you don't have to send them over the internet. So let's say I have a single user counter app. Wonder if I can run it still. You know what? I'm gonna make a new one. Oh, you know what? I broke it. Okay, let's do it in this way. Copy. Yeah, this isn't nothing interesting, and you only see basically this part. You see like 6 lines, right?
Yep.
So yeah, change is either Inca, Deca, or 1000, and 1000 is either 1000 or undefined, and counter starts with 0, but whenever change happens, it's gonna be the previous value plus change. And the Inca is 1, Deca is -1, and it displays the counter. So if I run it, yeah, I can plus, but minus. So this is a program. But what if I can have a way to say, you know, which nodes should go to the Croquet's model? That's sort of the pure state of the application, and which nodes should go to the view, that's like all other user interface. By saying that all realms, so models, those 3 nodes should go to the model part. I can have a Croquetify function that does a simple string transformation from this program as a text to those 2, the previous one to those 2 text chunks, basically. So the model would have those 3 nodes, but Inca and Deca are receivers coming from the view. And on the view side, Inca, Deca, those are in the original program, but you only add counter receiver that receives the model's value change. So the really simple text manipulation can make the single user program into multi-user programs. So this is running, should do this. And notice so I am joining late, and it's synchronized and both value changes. So that's how I can make a multiplayer application by just doing the text processing. And of course, I can do it for a Renkon-pad program. And wow, this part is getting a little bit hand wavy. Maybe I instantiated a few more windows here. And then I join that session. And I can move 2 windows at the same time. It's really like no delay because the reflector in this case is on my local computer too. So this is really unmodified Renkon-pad program made to be multiplayer up to a point. And the rotate, yeah, this isn't. So I can do rotation. So this is, I should make a new window. So, and I can join into this session. And again, notice the angle of those windows are totally synchronized. It's not like a faking. This is really the rotation angle is in the model and it's synchronized. But the thing is that I cannot edit the text here and it doesn't appear on the other side because content isn't synchronized. So that's what this says. It works very well for moving windows, but text contents are not synchronized. So that's
Is
where—
that just because your bridge into CodeMirror doesn't
Yeah,
expose the
exactly.
right data. Yeah.
So that's where is there the best of both worlds of local first and network first. And that's what like I want to work on if there's a chance. But so the one way to think about this is that like the real-time stuff will go through Croquet reflector. But what has to be synced in the like a text window and text content and stuff would have a separate like auto-merge document and use it. So it's a hybrid approach, which isn't like my purist sense. It's not great, but this is gonna work.
I don't
So-
understand the difference. What's the difference between the text in the window and the position of the window?
Because yeah, you know the window. So for example, this example, have you seen this example before? The physics
No.
simulation?
No, I haven't.
So like sometimes you do want to have a real-time physics simulation. And then like I was showing, you do not auto-merge, I don't think can merge like hundreds of objects position and rotation up, 60 frames per second and send the results to clients. If you run this, but if you run this in Croquet, like two windows are totally synchronized.
Dan,
And-
great timing to join.
What,
Okay.
well, but I guess I don't understand. Why not just do everything through Croquet?
Yeah.
Yeah, because I did the text editor. Oh yeah, so it's a practical reason. In Croquet, I did write a collaborative text editor, but then am I really going to do all the linked? This one does have like a linked, and the all sort of the language support and all that by
Well,
myself.
I think
could, but I don't-
Yoshiki, the text editor your chose is code mirror, right? And it has bindings that you could, bind to Croquet or to your Renkon signals. Like you could write a code mirror binding that reflected the code mirror state into
yeah,
the
okay.
same environment.
Yes, yeah, this text content could be, but still the point is that local first has other promises. So the promises are like a nice things about, being able to work when you're
Yeah,
networking
totally.
stuff. So you do want to have that aspect too.
So code changes in this diagram that you're showing us right now, where do they fall? Do they get kind of shared via Croquet or auto merge?
Well, yeah, that's there are options, and I don't have an answer, but we can do both, and the product gets different trade-offs, and I'm not ready to say which is better at this point,
Okay.
or
So
what combination of stuff is good. So
I think what's
yes.
interesting here is like if we assume sort of a fully functioning Croquet model, right? Then what you have is a unified stream of all events, like whether it's in auto merge or not, if we just set that aside, right? Like I think what you're describing is an interesting puzzle, which is, and this is the problem Alex and Dan have been fighting and having a real nightmare of a time with, which is, okay, you have this elaborate system. You're talking about a physics engine with all these bouncing balls. Dan and Alex have just had like complicated virtual machine state that changes quickly. And then you're generating millions of changes that you are durably and permanently recording in auto merge, which is like gratuitous and wasteful. The nice thing with Croquet is all these bouncing balls, like, yeah, you want to keep them synchronized, but you don't care where they were 5 minutes ago. Right? Is that accurate to describe sort of the Croquet trade-off? It's like you're guaranteeing that you'll have the same view, but you're not guaranteeing time travel to past states because it's expensive to retain all that.
No, it's not. Yeah, it's not actually. So that's the time travel to back in time. That's not implemented, but conceptually, that's like very simple.
Yeah, you could layer it on top by recording and retaining all the states.
No,
whereas
that's
auto merge-
already, that's built in. That is built in the Croquet.
So Croquet records the full state of everything forever?
Yes, it does, actually. Like
Oh.
if you go to the now defunct Croquet companies, Google Drive, yeah, anyway, so this is a different approach that's related to what Peter, you just said. On top of just doing the events, to make it croquet practical, there's a notion called snapshots and also persistent data. They are very similar, but a little bit different. And that's the application state really stored in one file or encrypted, so even no, croquet workers couldn't look inside, etc., etc. But anyway, so that's one data captures the entire application data of like time t, and the parameters can be different, but at 5-second computing time, a new snapshot is taken, and that typically takes like 50 milliseconds or so. So the 5 seconds of computing time, like 50 milliseconds will be spent, depending on the application, but then the one file is created and that's saved on the disk. So some of the applications we were using at Croquet was a meeting app, and that session was like 5 years old. So that one has like, I don't know, tens of thousands of snapshots going back in time. So if you do want to go back in time, yeah, launch the past snapshot on the disk and start from there. We can do that. We could do that. That's not implemented. So the auto merge could merge the snapshot data, decrypt and and then start from there.
I don't
The
want
local
to.
reflector can start the snapshot.
I don't want to take everybody's time here, but I think we could get Renkon-pad running in auto merged, you and I, in less than an hour, and then we could talk about like. I think what's interesting in a deep, like the technical problems here, I think are kind of straightforward. I think what's really interesting in a deep sense is this division of state that you want to synchronize or not synchronize or retain or not retain or allow to be edited offline and online, and then wanting to basically coordinate a snapshot. Because if you don't try and coordinate the snapshots across all of these things, then later you have potentially undefined behavior. Like, I don't know what it means to have parts of your data like linearized by Croquet, but then other parts of your data edited in an auto merge document, and then you come back online and connect to the Croquet server or Croquet equivalent server.
In that formulation, what Croquet model would store is really like a pointer or URL into that document, like one string. And actual content would be outside of Croquet snapshot. That's the way to do it in that formulation.
Yeah, the snapshot would be done as a performance thing, right? It's an optimization because based on the initial state in the stream of events, you can always compute the state of everything. Like that is the Croquet.
Right.
And so I think like for the stuff that Dan and I have been doing with Pyong, it would be more like, maybe the thousands of particles that are being simulated in the physics thing, you don't actually record their positions because they're computed from the initial state plus the physics plus all the events, like someone pushing on a particle.
Well, yeah, or maybe just make the snapshot manual.
It would be, it's interesting to think, like, if we wanted to solve this in like a robust PL way, are there things, like, I think it would suck to have to analyze for yourself, like, which parts of this app do I need to record in the auto merge document versus not? And what would be really interesting would be to try and use something like this data flow analysis to detect, like, will these variables have a perceivable effect that other peers could see? Okay, in that case, we need to record them. And then you could even sort of say like local only on things, like say, like if you had a particle effect, like confetti for JS, you could like mark the effects of that as local only. And then, everybody can have their own values. Like, I don't know what this
means. It's a little bit
means.
more dynamic though. Even this 2D zoomable interface, whether somebody's view should be synchronized to but you have seen my previous one, green light, where you can make others follow your view, right? So
Yes.
but you can uncheck that thing, and everybody can have different views. So whether some stuff should be in the view side or model side, that's like user interface design related. So the PL, you still, and also it's not like statically decidable kind of thing. So
Yeah, I think I think you're exactly right that it's a design thing, and I don't want to make other people listen to me ramble. That's your thing, but I'll say that when we did a talk about this a few years back, and I could try and find you the slides, it was sort of isolated. There's like things you want to synchronize and not, and then things that you want to persist and not for different reasons.
Yeah.
And it sort of forms like a little matrix. And there might be some other points on that like 2x2 chart, but I'd be happy to like go talk this through in depth with you anytime.
Yeah, a good reference here for the kinds of things you'd want to be able to do with state is like, John Underkoffler's systems where like you can see where someone's pointing. Here, that would be really cool too, right? So in order to be able to render where Josh is looking, like what part of the space Josh is looking at, where his cursor is, you would have to put that into the shared state one sees, or have Josh be broadcasting this like stream of events that say what he's doing.
Yeah, right. And that might, like, green light had it, and whether push it, it was a dynamic thing. So, yeah.
Can I jump in with a oh, sorry.
No, by the way, no, it's so this one says it's the end. So I'm basically done. So let's open to more questions, I think.
Cool. I've got a pretty divergent question, which I'm curious about, which is, if I understand correctly, the way that Renkon works is you define essentially top-level streams that can be functions of each other. And I'm curious about how kind of reuse or modularity or abstraction is possible in this setting. Because, for instance, if you write a set of streams that says, this is how a code editor works, then you might want to say, well, actually, I want to have 10 code editors.
Yeah,
and
so
it looks like, okay, yeah, go ahead.
No, there's a thing called a component. So it's basically you can have exactly like a dock window here is sort of like it's not component, but here's anyway, so the component is effectively like a cut out subgraph of your big dependency graph. And you can instantiate multiple of them and sort of store them in an array if you want, or data structure. And you can instantiate a subgraph as a one self-contained thing. It is self-contained because it has its own Renkon execution context. Basically, you can nest Renkon execution contexts running at the same logical time and instantiate more of those. Yeah.
Cool. Although it seems like you didn't use that, if I understand correctly, to implement, for example, like the Windows system.
No. I
and
don't
is there a reason to prefer one or the other?
Good. Well, yeah, I am skeptical. I have sort of the eat-or-like mentality sometimes. And of course, oftentimes, actually, in my view, this is an opinion, but the functional programming favors to have a global view, like everything is known to your program, and all type checks and everything known. So that view, like having the global view for certain things is good, but the component would hide some stuff in a separate execution context. So
you're concerned about information hiding.
For the bootstrapping this kind of stuff. Yeah, I would say not. And the Renkon-pad is sort of the small to 2,500 lines. I tend to think I don't need components for a program
okay, thanks.
programs. But like I said, it's an opinion. If somebody really wants to do everything with components, I would love to see it.
Does anybody else have questions? I want to open the floor. Alex and I really grilled Yoshiki a bunch there. Yoshiki, I am currently trying to get your code mirror. I'm trying to replace Renkon's state with an auto merge document in a side window here.
Okay.
Just because I think it should be actually really easy.
Yeah, that would be cool.
But let's see. I'm trying to think if there were other questions people asked along the way that I can resurface here.
I
Oh,
had
one question for you from. Oh, okay. Go ahead, Alex.
that I didn't get like enough, I guess, on, which is that when we were talking about syntax, like one follow-up question that I had about that is like, are there parts of JavaScript that just don't make sense as a Renkon-pad program? So that, like, for instance, can I always use functional abstraction in any way that I normally do and it'll just work? Or are there some things to watch out for? And if so, is there anything that you can do when you take this, like hijacking JavaScript syntax and providing different semantics? Like, have you come up with some ideas that can at least help the programmer not do the things that you don't want them to do?
Yeah, this
Linting.
is a problem of using like your own language and you tend not to see them. But let's say, like if you have a while loop, while true or infinite loop, yeah, that wouldn't do. And if promises are valid in, I don't know, there aren't too many I can think of, but Adam probably knows better. But
There are a few.
there are, but yeah, not too many if I'm not totally wrong here.
Yeah, stateful network things can be hard to clean up if you're not very, very careful.
Yeah, if you mutate, yeah, you could be very wrong. Yeah.
But if you build up connections, for example, and you do something reactive and you lost the thing that you need to close, basically leaks.
No.
It behaves like a
Well,
leak.
yeah, that's right. Well,
You can be careful and it works beautifully, but it's possible to end up with a lost reference like if you have a bug and you leaked it, the current semantics are not enough to go back and find the thing you leaked and get rid of it. As a simple example.
So I have another maybe angle of a question on Alex's question, which is that I have a model of how the JavaScript transpilation is working here, and you can tell me if it's right or wrong, where I feel like all that you're doing is taking code in your code editor, and you're basically breaking it up into top level declarations and statements, and then you're analyzing each of them for its references, and basically each one becomes a node in like a notebook. So, but then within those expressions, I don't imagine you're like descending down a whole abstract syntax tree to do super complex stuff. I feel like
that's
you're
yeah,
up top level.
although
Is that correct?
Nested thing treated to make separate nodes. So but yeah, over at a high level, that's pretty much the
So
speed.
for instance, something that you could do,
Yeah, so
I don't think you should do this, but something that I imagine you could do would be add a new syntax like a row of dashes and just tell the user you have to put dashes to separate these top level nodes. And then essentially you wouldn't really be, in some sense, you wouldn't really be transpiling at all. You would just be like taking the stuff in the code editor, splitting it with the dashes, and then doing your analysis to network them as reactive nodes. Or maybe that's too simplistic.
Yeah, we can talk. Yeah, I shouldn't say, but my intuition says that that's too simple. But I don't know actually. So just yeah. So whatever the thing was, of course each statement would become a function, and that whose arguments are its dependencies, and the evaluator figures out. But here, the earlier example, it's basically, it's an event listener but wrapped in heap. So there are two nodes here. So the transpiler nodes to create separate sort of anonymous node for this part, and this outside behavior keep depends on that anonymous node kind of thing. So it's not really only top level. You
see.
kind of have to handle the nested ones.
I see.
So Joshua, so earlier, like last year, there was a question about whether a promise should be an event or behavior, if you remember. And I said one thing, but I changed my mind, and it's actually like any other nodes here, the type, whether it's a behavior or event, should just do a better propagated sort of lattice. When a node depends on one or more event, that node would be event. But if a node depends on only behaviors, that's a behavior, and the promise should be the same. If the input, any input for the node that creates promise is an event, it should be an event. Oh yeah, so for that matter, yeah, one thing I didn't show is that, this one is kind of broken already. I'm gonna restart. So my little inspector in the runner. So this is running Renkon program, but this button here shows the inspector, and the order here is the order of the topological sort. And the values you can see, like here, like values, and event, at any time, events don't have any value actually, because the time you are viewing here, the value is not there. But there are a few promises inside, like loading the Preact library, and where is it? Yeah, anyway, so the types are determined when the set of node definitions are fixed. And whenever you modify one or two, it says, oh, this is a different thing. So it does the whole analysis again and keep going.
One related question here is obviously, you know the system inside and out, and I have now read a bunch of Renkon-pad, but I have a hard time producing Renkon because I don't know all of the things. Do you have like a markdown with a list of all the combinators and some examples? Like, do you have a docs page?
Yeah, this one. So the Renkon has this is mostly up to date. Yeah, so there's a Renkon core, which is this, and there's a Renkon-pad. Oh, this doesn't do that. I thought it's gonna take me to. Yeah, anyway, so Renkon here, and then there's Renkon-pad. And by the way, yeah, there's a Discord somewhere. And yeah, this one tells you how to use it, and the previous one tells you like how the language look and works.
I will share both of those links in our Discord for convenience for everybody else.
I want to mention that there are various moments of delight building things with Renkon. They are, as you sort of build certain things, there's the delight of it making sense at various levels, but also some programs are just much simpler. And certain ideas are much cleaner to make sense of. Although, of course, you can write C in any language. It applies, in my experience, to trying to do.
So, Adam, this is Dan. Could you mention just a couple of those? Because I've always thought that one of the ways into a neat new system is to think of a few things that you think should be just really easy, and I'm just wondering what things ring that bell for you.
Yeah. Personally, so unfortunately we have like capital B of behavior and capital E event, but the word behavior and the word event are more commonly and generally useful. So when you have a lowercase e event-driven system that you're working with, I have found the distinction between capital B behaviors and capital E events to be fantastic. Without them, it's very easy to accidentally build cycles if you have like a basic dependency evaluation system. Oh, this value changed. Oh, okay, well, let's update a bunch of stuff. But many times you have a value, a behavior, capital B behavior, take on a new value, but you don't want to use it until you have a new capital E event to process with it.
Yeah, in other words, so the distinction itself may not be like novice friendly, I admit, but once you see the value of the distinction, it's very nice. And yeah, it's a question of how far you can do. So if you look at my screen, I'm showing that XYZ thing. In this formulation, for example, like you kind of don't have to care about the distinction. But yeah, at the one point, sometimes you come to the distinction and, oh, I have to convert that or such.
But Dan, I think you missed a couple of, like, you got here later, right? So you missed a couple of demos that to me felt like these moments that are of delight or whatever. One of them was this thing with a timeout when you move the mouse or whatever, something changes color and, for kind of a couple of seconds.
Yeah,
that felt really good when Yoshiki was doing it. The other one that I thought that I wish we could have gone more into like the weeds with was the Guitar Hero kind of demo, which I bet there are a few of these delightful things in the implementation of that would have been kind of hairier to do without this notion of events and behaviors. Although that's more of a conjecture because I haven't really
seen. So besides events and behavior, so that rhythm game, it's an interesting question that like where those event handlers should be, for example. And the initial idea you may get that, oh, you're gonna have a click handler for each of those dots coming down. But you cannot do that because if you miss it, you still want to say, oh, you missed it. So those lanes have event handler. Let me, so then this is multi-touch. So it's like I don't do too much of like electrical things, but you can think of that as a 7 wires coming into basically this judgment process. And then it's like judgment comes out from the other side. So yeah, the way you think about how to write this is interesting, certainly.
Right. Yeah. Now I apologize for missing out on the early part. I was camping up behind Quincy.
It's fine. So what Alex was referring to was this one. Anyway, so maybe it says the two events, one event stream capturing the mouse move, and it whenever new mouse move comes, it gets a new value. But the other one is 500 millisecond delayed. And this one says when the delayed one and the sort of the previous sort of real one are the same, the last values in those streams are same, you mean the mouse pointer stayed at the same location for 500 milliseconds. So if I move here, it's red, but if I stop and wait for 500 milliseconds, it's gonna be blue. And instead of trying to do cancel timeout and set timeout and all that, you can just say your program is like this. Your value is comparing the delayed one. And
Yeah, that's really nice doing that declaratively. I like that.
yeah.
Thanks.
And if you wanted to turn this into an event, like a debounced thing, it would be one more line to write.
Yeah.
Events change, and now you got a pulse when someone calmed down. They stopped typing in their editor, and you should go and save it to the network, for example.
Nice.
I have a somewhat divergent question, which is comparing this to something like Smalltalk or eToys or something like that, which has a very rich object system in which graphical objects on the screen have like very real identities and they have code attached to them. This is a system where you have basically a sort of a pool of code. You've got like this ocean of code with all these reactive variables that might go out and change the DOM, but you no longer have sort of systems of like visual objects that do things. And I'm curious if you have reflections on those two different, like, does that feel like an important dimension to you of like
Well,
deviation?
you can build one and if you build your graphical objects with Renkon-pad windows, maybe modify the looks and stuff. I don't see
I mean,
any
you can
difference
build
there.
anything out of anything, but I'm just curious. Like, it seems like this sort of spirit of the system is kind of different. Or am I wrong?
Good. Well, yeah, like an alternate reality kit versus like croquet. I don't have a good answer, but yeah, the spirit. I don't know. It's all bits and electrons moving around. So the
Okay.
identity, I don't know. Window logically, like array of that ID strings, I can say that is like the identity of the thing.
Or like another concrete angle I could give on this is that in a system like Smalltalk, if I see something on the screen that's part of my interface, I can probably like click on it and look up its data and look up its code. Here, if you have that Guitar Hero game, I can't click on a part of that Guitar Hero game and like learn more about it, or can I?
No, not in this implementation.
So it's sort of more like it's closer to maybe traditional web development practices.
In some ways, yeah. In the end, things are rendered with DOM elements in the game.
Right,
So
rather than having a native representation.
You could imagine, yeah, this doesn't depend on any graphical, it doesn't have any hard-coded graphical library choice. So you could imagine to render everything in your canvas and you know which pixel belongs to which object.
I'm gonna jump in here and play Time Cop because we've gone for a full 2 hours. And while I want to encourage anybody who has the time and wherewithal to carry on, and Yoshiki, I'd love to talk to you about this auto merge thing I'm tinkering on the side as soon as you would like.
Yeah.
I want to thank you for taking your morning to spend with us and to share the system with us. I think it's a fascinating system and quite different than other systems that I've seen in ways that having this extended time to talk about really helped illuminate for me. I think I might suggest that thinking about how to communicate this talk in print would help other people find it more legible. I don't know what that means exactly, but like this is great and very helpful for me and quite inspiring. Thank you. I want to thank everybody else who took time out of their morning to join us, to ask questions, to be here. Always appreciate people turning up. We are always hoping to do more of these things, but they take time and energy to organize, and we're bad at that sometimes as a group because we're also busy with other things. So hopefully we'll do more of these in the future. Really appreciate it. And I'm going to set a good example because we have a demo tomorrow that I'm trying to make some progress on. So I'm going to drop off, but I'll leave the call up. Please feel free to continue. But if you have other places you need to be, this is your moment where you can duck out. But by all means stay and continue the conversation.
We
And
could also
Yoshiki,
move
ping me
the
later.
conversation to the community thing in Discord.
Yeah, that's a nice idea. We could wrap
Better
the
so that we
recording
can
up here.
stop the video. Yeah.
Yeah.
Okay.
All right. Well, good to see you all. Thank you again for coming.
Yeah, thank you.
Appreciate you taking the time. And Adam, it's a cool system. Thanks for contributing to it as well. And we'll see you all next time.
Thanks, Yoshiki and Adam.
Thank you.
Thanks a bunch.
Everybody.
Um,